Okay. So I'm starting with number 13. And it is n squared plus 10n plus 25 over n squared minus n. And we are simplifying this. So the first thing that we're going to do here is we're going to factor. All those factoring things that we've done, we're just going to keep doing that. So when I factor this, my sum is 10 and my product is 25. So that factors to n plus 5 and n plus 5. In the bottom, I don't think I wrote the whole problem down. In the bottom, I'm left with n minus 1. Does anybody have their book with them?
No.
Okay, that's okay. I'm pretty sure I didn't write the second part of this problem down.
I don't have my book, but I have some notes.
Okay, look at number 13 and see if you've got that one.
Yeah, it's times 5n to the third power.
So the original problem is times,
5n to the third power.
okay,
Minus 3n to the second power.
okay. Minus 3n to the second power,
And then over 5n to the second.
okay.
Plus 22n minus 15.
Oh, now I remember why everybody was struggling with this one, because it was that factoring. Good. Okay. So, when I factor this numerator, I can take an n squared out, and I'm left with 5n minus 3. Now, the thing that has gotten everyone confused is how to factor 5n squared plus 22n minus 15. So this is one of those factoring situations where we do not have a 1 in front of the squared value. Okay, so we are used to seeing a 1 there. And so we have to do this one with the sum and the product. Or we have to multiply our AC method right here. So 5 times negative 15 is our product. So our product is negative 75. And our sum is positive 22. So I'm looking for two numbers multiplied together, give me negative 75, and added together, give me 22. And those two numbers are positive 25 and negative 3. And so what we do now, and this is bringing back all memories from last chapter, is we split that middle term. So I have 5n squared plus 25n minus 3n minus 15. And now we factor by grouping. So I look at this part, and then I look at this part. So I take a 5n out. Okay, and then I take a negative 3 out. So this factors to 5n minus 3 and n plus 5. And as I was listening and hearing people talk about this one, it was factoring this right here where students had the issue. We had kind of forgotten how to factor that. So now I am going to put this here. Okay? So it's remembering how to factor those that do not have a 1 in front of the squared value. Can I erase how we factored this? Okay. Okay. So now we can start canceling things out. So I have n plus 5 here and an n plus 5 here. I have 5n minus 3 and 5n minus 3. I also have an n in the denominator and an n squared in the numerator. So that cancels, and I'm left with just an n to the first in the numerator. Okay, so my final answer here is n times n plus 5 over n minus 1. You might choose to multiply that n across the n plus 5, but you don't have to. It's not necessary to do that. Okay. Can I go to the next screen? Okay. So this is number 14. X squared minus 2xy minus 3y squared over x squared plus 9y squared divided by 2x squared plus xy minus y squared, 2x squared minus xy. The factoring might have caused some confusion on this one, but before we factor, I want us to do our keep, change, flip first because we are dealing with division. So keep, change, flip occurs first because we're dealing with division. So I have x squared minus 2xy minus 3y squared over x squared plus 9y squared. So I keep that first rational. I change my division to multiplication, and I flip this. So I have 2x squared minus xy, 2x squared plus xy minus y squared. Okay, now I factor. Now, this one right here, x squared minus 2xy minus 3y, I'm going to write this down separately just for a second, even though we have a 1 there. I think you guys get confused because of this, the y and the y squared. All that means is you're going to have something x plus or minus something y. That's what that's going to look like. Okay? My product is -3, and my sum is -2. So instead of having x minus 3 times x plus 1, we're going to have x minus 3y and x plus 1y. Okay? It's that, I think that y is what confused you, is that y on the end. So all we've done is I factored x squared minus 2xy minus 3y squared. So I have x minus 3y and x plus 1y. Okay? Our x squared plus 9y, it doesn't factor at all. Be careful with that, because sometimes students want to make that a difference of perfect squares, but it is not a difference of perfect squares because it's being added. So you cannot break down x squared plus 9y squared anymore at all. That's as far as it goes. Now our numerator, okay, we can take out an x. That's all we can take out is an x. So x, then I'm left with 2x minus y. Okay, now I'm going to factor this trinomial. And again, we've got our x's and our y's. In some ways, because we have to factor this by grouping, it's a little bit easier to distinguish with the y's. we do have to have our sum and we do have to have our product. And the reason for that is because of this 2 right here. And that's, we're going to split this. So we have to do 2 times negative 1. So our sum, sorry about that. Our sum comes from the number that's in front of the xy, and that's a 1. Our product comes from 2 times negative 1, and that gives us negative 2. So our numbers here, for number 14, our numbers are going to be positive 2 and negative 1. So then I have 2x squared plus 2xy minus 1xy minus y squared. So I think we have forgotten a little bit how to do that factoring when that a isn't 1. So then I can take a 2x out of my first 2. Then I'm going to take a negative 1y out of my second 2. So this factors to 2x minus 1y times x plus y. And that is what goes in the denominator right here. Okay, can I erase the factoring? Okay, so I'm erasing the green. Okay, so now that we've got everything factored, and again, this is where students got hung up with the factoring, is that one right there. Okay, so we have 2x minus y and 2x minus y. Then we have an x plus y and an x plus y. And I think that's it. So in the numerator, I'm left with x minus 3y and x. So I have x times x minus 3y. Then in the denominator, I have x squared plus 9y squared. Okay. Can I go to the next screen? Oh, no, you're fine. Take your time. That's why I asked. You're good? You guys good? Okay. Okay, number 16. Okay, number 16. It is addition. Addition. So we've got 3 over 2n plus 5 over 3n minus 1 over 9. Okay? So we have to determine what our LCD is. I'm going to rewrite this as 3 over 2n plus 5 over 3n. Then I am going to move that negative to the top. Okay, so I have plus negative 1/9. Then I'm going to take my 9 and I'm going to write it as 3 times 3. Just so I can visualize all the different numbers that I need in my denominator. So then I start with this 2n. So my LCD is going to have a 2 and it's going to have an n. Okay? Then I look at this one. And what's missing? The 3. I've got the n, but I don't have a 3. So I've got to put a 3 in there. Now for my last one, I have 1 3, but what do I need?
The other 3.
I need the other 3. Okay, so this is going to be my LCD right here. And I would leave it as 2 times n times 3 times 3. We can we can multiply it all out later, but I would leave it like that right now. Now I go back and say, what is missing? What is missing from each one of these? So my first one, I've got the 2 in the n, but I'm missing the 3 times the 3. And since I multiply the bottom 3 times 3, I have to multiply the top times 3 also. For the second one, I have a 3 and I have an n, but I'm missing a 2 and a 3. So I have to make sure they're all accounted for. Okay? On my last one, I've got the 3 and the 3, but I'm missing the 2 and the n, so I'm going to put that in. Okay? Now, I've got my denominator. Okay? 3 times 3 times 3 is 27. 5 times 2 is 10, times 3 is 30. Negative 1 times 2 times n is negative 2n. Now, at this point, I can combine these like terms. So I'm left with 57 minus 2n. And here, when it's just multiplied in the denominator, I go ahead and combine those, and I get 18n. Okay? We are just working some of the harder problems from homework.
Okay.
That's what we're working on.
This is kind of where I've left off.
Oh, good.
This is from this morning, I think.
Yep, this is number 16. So we're about to do number 19. Do you guys have it written?
Mm-hmm.
Do you want to take a picture of this real quick?
Yes.
Okay. I guess actually you'll get it on the.
Oh.
You're fine. You're
Yeah,
gonna
my
get
phone's
it.
dead.
You're gonna get it when I do the solutions. So you'll have it there too. Okay. Now we are looking at number 19. Number 19. So this is 3 over n squared minus 5n minus 36 plus 2 over n squared plus 3n minus 4. Okay. First thing I do is I factor that denominator. I've got to find my LCD, and because these are trinomials, it's always a good idea to look and see if we can factor that. That's super helpful to make sure that we can do that. So I've got 3. Here I've got n squared minus 5n minus 36. My product there is negative 36. My sum is negative 5. So the numbers, it's 9 and 4. The 9 is going to be negative. So it's negative 9 and positive 4.
Is
So,
that right when you said factor and LCD? Is that just like the steps?
Yeah,
Factor
you
first and then find LCD?
yes, you've got to factor the denominator first. And after you factor the denominator, you can find the LCD. And let me write denominator right there. Okay. And then n minus 9. Okay. Now here, the next one, we've got negative 4 as our product, and positive 3 is our sum. So that's going to be negative 1 and positive 4. So we're going to have n minus 1 and n plus 4. Okay. Now, I just always start right here for my LCD on the left. So I'm going to go ahead and write down n plus 4 and n minus 9. Okay? Now here, you'll notice that n plus 4 is already written down. So I only have to write down the n minus 1. Okay? So it's n plus 4, n minus 9, n minus 1 is my LCD.
Should n minus 1 go first? Like all in order? Does that make sense?
Yeah, no, I understand what you're saying. It doesn't have to for that. Typically what goes in order is the exponents. So like n to the third would go first, then n to the second, and n to the first. It doesn't matter what order you write this in. You certainly could write n minus 1 first. Okay?
Is that a negative on the denominator? Like
The red dot,
sign?
nope, it's just,
What about the other?
yeah, it's just pointing out what I'm looking at any given time. Yeah, nope, you're good. Okay, so now we're going to figure out what's missing. So here I've got 3 over n plus 4 and n minus 9. Okay, so n plus 4 is there, n minus 9 is there. What am I missing?
N minus 1.
N minus 1. Okay, then for our next one, I have n minus 1, n plus 4. I don't know if I can get in there and erase that one. Yeah, I figured I was going to do that. Okay, so for this one, I've already got n minus 1 and I've got n plus 4. So what am I missing for this one? N minus 9. Good. Okay, now at this point, you could write the denominator once. Okay, and it doesn't matter what order you put those fractions in. You can write it once. I'm going to distribute. So I've got 3n and then 3 times negative 1. I'm distributing again. So I've got 2n minus 18. Okay. I've got like terms. So my final answer here is 5n minus 21 over my denominators. And I definitely would leave this denominator not multiplied out, because you would end up having to do a trinomial times a binomial. Okay? Can I go to the next screen? I'll post the rest of them. Have a good day. Have a good weekend. It is okay to go? Okay. Okay? What did you say? I'm sorry.
I said I am at least.
Oh, okay. Gotcha. Okay. Sarah, you're good?
No.
Good. Okay. 21. Okay. This is one that
Homework is the odd, or all of it, right?
it's all of those numbers. So
no odds this time?
there's no, it's all, because we're just doing a couple of different sections. So it's like 1 through 6 all, and then I think we start at number 11 through 26 all. Yeah. So it is all, but we're not doing every single problem in the chapter review.
Mhm.
Okay. In this particular one, we have multiplication and we have division. So the first thing that we want to do is our keep, flip, change, but it's keep, change, flip. Okay? Keep, change, flip. So I'm going to rewrite it. So I'm going to have 2x squared y over 3x times xy squared over 6. And I am flipping the last one because that's where the division sign is. So then I end up with 9y over x. Okay? Now, if it's on the top and it's on the bottom, I can cancel it out. Okay? So do you see how I have x squared right here? We've got x squared. I can cancel out x and x because x times x is x squared, and x squared means x times x. Okay? Now, my 3 becomes a 1 and my 9 becomes a 3. I'm going to do my 2 and my 6 now. My 2 becomes a 1 because 2 goes into 2 one time. 3 and 2 goes into 6 3 times. Okay? Now, do you see how I have another set of 3s? One on the top and one on the bottom? That cancels as well. Okay? Sometimes we think we can't cancel again because we already took one number into that, but we can. We can. Okay? Then I'm left with x. Okay, I have a x right here. I have a y here. I have a y squared here, and then I have another y here. So that's y to the what? It's not the fifth. So the x just stays the same.
The fourth?
It's the fourth, okay? It's the fourth. Because this is y to the first, this is y squared,
Oh, yeah.
and this is y to the first. And I know I used kind of a fat marker, and it's harder to see that. Okay?
I just added one out of nowhere.
That's okay. Sometimes our brain just makes stuff up, and that's okay. Okay. I'm going to do number 26 right now. I don't mind also doing 25 because this is what we did on Wednesday. Okay. Can I move forward? Okay. So 26 is the long division. Now, I don't mind doing synthetic division, so it's really whatever method you're going to use. I'm going to start with long division, and then if you want me to do synthetic, I will. So I have 3x squared plus 5x squared minus 6x minus 2. And all of this is divided by x plus 4. Okay, so I'm going to do long division first. Then if you want me to do synthetic, I can. So my x plus 4 goes in my box. That should be a third, I think. I wrote it down wrong. Shay, can you just check in your book and make sure it's 3x to the third? I wrote it down wrong on my piece of paper.
Yes, it's 3x.
Okay. Okay, and so that 3x to the third plus 5x squared minus 6x minus 2, all that goes inside the box. Okay. And then we ask ourselves, x times what gives us 3x to the third? X times what gives us 3x to the third? And that's going to be 3x squared. Good. 3x squared. Okay. Now I multiply. 3x squared times 4 is 12x squared. 3x squared times x is 3x to the third. And now we have to remember that we are subtracting right here. Okay? That's a place that sometimes students make mistakes, is they forget that we're subtracting. Do you see how this 3x to the third minus 3x to the third cancels? You want that to happen. If that doesn't cancel, then you've made a mistake somewhere. Okay? 5x squared minus 12x squared is negative 7x squared. And my next step is to bring down that 6x. or negative 6x. Okay? So now we say x times what gives me negative 7x squared? X times what gives me negative 7x squared? Good, negative 7x. That's exactly right. Negative 7x times 4 is negative 28x. Negative 7 times x is negative 7x squared. And since we are subtracting, what happens to that negative and negative? They become positive, okay? So that's going to be positive 7x squared and positive 28x. Okay? Again, negative 7x squared and positive 7x squared should cancel. Negative 6x and positive 28x are 22x. Okay? Now I'm going to bring down that negative 2. X times 22 is what would give me 22x. 22 times 4 is 88. 22 times x is 22x. And we are subtracting. Now I have promised not to give you one that has a remainder. So on your test, you can count on not having one as a remainder. When you do get a remainder in the future, when you take 144 or a different algebra class, then you might have a remainder, and you would write it just like that right there. So my final answer is actually all of this. Is my final answer. Shay?
No, it's messy.
I'm messy?
No,
okay.
no.
It is messy. The answer is messy.
Yeah.
Long division is messy, and the answer is messy.
Mm-hmm.
Now, do any of you prefer synthetic?
I don't understand.
Okay.
That was the first time I ever saw it.
Okay, and that's fine. So if you take 144, you'll see it again, and you'll just pull pieces from it. So you'll be okay. You'll be okay. I just wanted to show you synthetic if you prefer that. Would you like to see 25 also? Okay. So, Shay, I'm going to need you to read it to me, but you finish writing that down first.
Okay. 25?
Yes. Okay, can I move off this screen?
Mm-hmm.
Yep, okay.
It's parentheses 18x squared plus 9x minus 2.
Okay.
Parentheses. And divided by parentheses 3x plus 2.
Okay, now this one does not have a remainder. And so this one is more like what you'll see on your test. So I'm going to put the 18x squared plus 9x minus 2 inside. Then I'm going to do 3x plus 2 on the outside. I should have changed my color, but oh well. So now I say 3x times what gives me 18x squared? 6x, good.
And that has to go over the second number, like 9x.
You will be happier if you do it that way, okay? That is the ideal way to do it. I can't say if you put it over the x squared that you'll get it wrong. It's just you are going to have a better process if you put it over that x to the first power. That's where it belongs, is over that one. Okay? Then I do 6x times 2, which is 12x. 6x times 3 is 18x squared. And we are subtracting. okay? And if you don't cancel these out, if that leading thing that you're trying to get rid of doesn't cancel out, you have made a mistake. Okay, so that's
Is it always on the left where it's going to
Yes.
cancel?
it's always on the left. It's always going to be, and then like now I've got negative 3x minus 2. So the thing I'm going to get rid of this time is that negative 3x. That's what I want to get rid of. Okay? 3x times what gives me negative 3x? 1 times 2 is negative 2. Or negative 1 times 2 is negative 2. Negative 1 times 3x is negative 3x. And we are subtracting, so these change. Instead of subtraction, we have addition. This cancels, and this cancels, so I'm left with a remainder of 0.
These are just 6x minus.
Yes,
Okay.
6x minus 1. So that one is the simpler problem, but I did, want to show you both. The next two are rational equations. So I'm doing 29 and 30. You may not have gotten that far on your homework, but I want to do those problems with you also. Can I move off the screen? Okay. Okay, so here is number 29. This is 4x plus 5 over 3. 2x minus 1 over 5 equals 2. Okay, now we are able to do this way because we have an equal sign. The directions are solved and we have an equal sign. That's why we are allowed to multiply
The first step.
everything by the LCD. Yes, everything by LCD. Now, I'm going to move my screen backwards. Okay. Here, we were adding. We were straight adding. There's no equal sign. So we end up with something that looks like 57 minus 2n over 18n because there's no equal sign. Here, we are simplifying. Okay? We are simplifying. It also may say add or subtract, but that's what we're doing. Here, so that's the other thing we're doing. We're adding. Okay? We're simplifying, adding and subtracting. The difference between this is we have that equal sign. We are looking for a number.
Isn't this a quadratic or not? Or just
It does not turn into a
Okay.
quadratic. It doesn't. Sometimes they do turn into a quadratic. This one will not turn into a quadratic. This will turn into just something linear.
So in rational equations, our first step is always multiply everything by LCD.
Yes, and that's rational equations. And that the key word there is that equals. Okay? Okay. So, first thing I want to do is figure out what my LCD is. I have a 3 and I have a 5.
15.
Yeah, so my LCD is 15. I'm going to write it as 3 and 5. And the reason that I'm going to write it as 3 times 5 instead of 15 is because I can cancel some of these things out. So I am going to multiply everything by 3 times 5. Okay? So I have 3 times 5 over 1 times 4x plus 5 over 3. Okay. Then I have 3 times 5 over 1 times 2x minus 1 over 5. And then I have essentially 2 over 1 times 3 times 5 over 1. Because in that one, nothing's going to cancel out.
So say you forgot that stuff, would it still work if you did just use 15?
Oh, yeah, absolutely. Yeah, it works. The reason that I do it this way is because, like, in the next one, we're going to have variables. And so I just kind of show you how that works. But, yeah, if you multiplied everything by 15, you'd be fine. You would be fine. Okay? So here, it shows me exactly what I cancel out. So I'm left with 5 times 4x plus 5. Okay? Here, my 5's cancel, and I'm left with 3 times 2x minus 1. Okay? Then I have 2 times 3 times 5. And that's 30. At this point, this is likely an equation that you know how to solve. Okay? And it's not a quadratic because nothing in here is x squared. Okay? That's why it's not a quadratic. So I have 5 times 4x, which is 20x. 5 times 5 is 25. 3 times 2x is 6x. 3 times negative 1 is negative 3. Okay? 20x and 6x is 26x. 25 and negative 3 is positive 22. Okay? So I combined like terms there. What's my next step? Good. Subtract 22. Okay, then I'm left with 26x equals positive 8. And I'm going to have to go right there. Okay. My next step is to divide by 26. And that is 4 over 13. I realize that's written on top of the hand. It's a little bit better.
I like that blue color.
Yeah, it's probably my favorite color.
Oh, cool.
You'd never know, right?
Yeah.
Okay?
Yeah, that's my favorite color too.
Yeah, I love that color. Okay, can I go to the next screen?
Mm-hmm.
Okay, now number 30, or one similar to number 30, is what you're likely to see on your test, because it has variables in the denominator. Okay, so we have 3 over 4x plus 4 over 5 equals 9 over 10x. Okay? Now, you don't have to do it this way, but it's easier to go ahead and break things down. So instead of writing 4, I'm going to write 2 times 2. Okay? So once we get variables in there, it's easier to break them down so that we can figure out what our LCD is. Now, 5 doesn't break down at all, so I can just leave it 5. Okay? But 10 does break down. Okay? So I'm like, oh, you know what? I'm thinking about this differently. There we go. 10 does break down to 2 times 5 times x. So when I figure out my LCD, okay, I'm going to start with 2 times 2 times x, and I'm just going to write it down. 2 times 2 times x. Okay? Then I'm going to look at this one. Is that written down? No. So I've got to do times 5. Okay? Now, when I look at this one, I already have a 2, I already have an x, and I already have a 5. So do I need to add anything else to this? No. Now, you could, if you wanted to, multiply everything by 20x, if you wanted to. Okay, because 2 times 2 times 5 is 20, and then we've got our x. Completely fine. I usually keep it this way because then I can cross out what I need to cross out. Okay? So I am going to multiply everything times my LCD, which is 2 times x times 5. Okay? Okay, so I'm going to multiply that times 3 over 2 times x. Then I have 2 times x times 5 over 1 times 4/5 equals 9 over 2 times 5 times x. Okay. Now, here I've got 2 that can cancel, another 2 that can cancel, and another x that can cancel. So I'm left with 5 times 3. What's 5 times 3? Good. Here, the only thing that I can cancel is the 5. So I'm left with 2 times x times 4. 2 times 2 is 4. 4 times 4 is 16, and then I have an x. Okay. Then I can cancel a set of 2's, an x, and a 5. And so I'm left with a 2. So 2 times 9 is 18. Okay. Subtract 15 from both sides. I'm left with 16x equals 3. I'm going to divide by 16. So x equals 3 over 16. Sure. No, that's fine. I do not have any more.
Okay.
Yeah, that's all that I have. Okay? So is there anything else that you'd like to see me do?
I think that's it for me.
Okay,
I think that's it for me.
good. Sarah, how are you feeling?
Let me see, there's actually one problem I had a question about on the homework.
Oh, cool. Do you know which one it is?
Let's see.
No, you finish writing this down, and then we'll get it for you. You got it written down, Sarah?
Yes.
So I can go to the next one. Okay.
Problem 39.
I'm sorry.
Problem 39.
Number 39?
Yes, ma'am.
Okay, can you read it to me?
Yes, ma'am.
Okay. For some reason, I thought are we assigned number 39?
I don't remember it.
I thought we stopped at 36.
Yeah.
We did stop at 36.
Stop at 36, yeah. 'Cause I'm
Does that make you happy?
Yes, ma'am.
Yes.
Don't worry about it.
29 through 36, that's what you finished with.
Yeah.
Yeah.
That's right.
That's good news, right?
Yes, ma'am.